All right, so getting into the practice problems here. Number one says write the equation for the alpha decay of plutonium 244. All right, so you got to find plutonium on your periodic table. So plutonium is Pu. So Pu, and then and it's number 94. 94, and it says it's plutonium 244. So 244 goes up there, and it's just decaying, and it's alpha decay. So right off the bat, we can write down a helium nucleus. So He, and then it's going to be 2, and then it has an atomic mass of 4. Okay, and then all this one's going to be is just plus something, right? So what has to be left here? Well, I know my new particle has to have a atomic mass of, well, it has to be 92. Or sorry, atomic number, sorry. I know that because my charge has to add up to the same number. So 92 plus 2 gives me my original 94. And I know that my atomic mass, or my nucleons, has to be 240. Okay, so then I have to look back to my periodic table, figure out what that is. So 92 is uranium. So this must be uranium 240. So you could write that out again as uranium 240, something like that if you wanted to, or you just leave it like that. Okay, write the equation for the beta negative decay of oxygen 19. So oxygen on your periodic table is 8. So we go oxygen, it's going to have 8 protons, and it's saying that we've got 16 nucleons. Okay, and it's going to decay. So it's going to decay into, and then it's beta negative, right? So we know that beta particles are electrons. So it's negative, so we got -1. And has a charge of 0, or sorry, 0 nucleons. So then what is this thing going to turn into? Well, we just got to make sure conservation of charge and conservation of nucleons plays out. So we're going to have, well, my charge here, this must be 9, right? Because a 9 minus 1 will give us our original 8. And then our number of nucleons has to stay the same, so it'll still be 16. So I look back to my periodic table, this must be fluorine. So F. And then one more thing. There's one more thing that I need to do here, right? Because remember, conservation of energy or mass energy probably isn't being conserved here. There's one more missing thing. So I had a electron, and what else is always tacked on with an electron decay or beta negative decay? Well, that's going to be so plus, and then it's an anti-neutrino. So you get the little symbol above it, right? So that'd be the whole thing there. Now, beta positive decay for fluorine 17. Okay, so we'll say fluorine, and fluorine we already know is 9 for my charge, and it's 17 for the nucleons. Okay, and it's going to have a beta positive decay, so that is a positron, or an anti-electron. So that's going to be still E, but it'd be 0, and then +1 for my charge here. Okay, so what's that going to turn into? So that one must be turning into, so this must be 8. Right, so that's going to be 8. Well, that's oxygen. I know 8's oxygen. And then 17 is what my nucleons are going to be. But then remember, what always comes along for the ride with a beta positive decay? Well, that's going to be a real neutrino. Not an anti-neutrino, but a real neutrino. So just I always write a V, but it should be like the little flared out ends on it. Okay, so hopefully that made sense. All right, last one. So we're going to do a graph here. I think what I'm going to do is I'm going to just, you take a second, see if you can graph all these points, and then we'll do it together. So I'm going to pause it and then just kind of throw it up on the screen here. Okay, so there is our graph after you plot the points. And now it just says, what is the half-life of technetium? All right, so in order for it to be a half-rate, right, if I got my decay rate, so it's going to be up here, and we're going to take really half of that, right? So now down to 40. If I come straight across here, and then right here, right? So looks like about 17, yeah, So I did that. So then decay rate would just be 17 minutes. So, or sorry, half, what the half-life, I mean, sorry. So T1 half would be 17 minutes. And that's really it. So you guys will kind of use that idea. So once you have your half-life, then you could put it into your N is equal to, actually usually capital N. And something's wrong with my pen here. All right, N is equal to N naught 1/2 to the, and then it's N but this N, right, that can be made up of time over half-life. Okay, so then now you have this, and now you could use that as your, or in your equation there. Just one more thing I just kind of know that I think I kind of skipped over in the last video. One little part here, sorry to jump around, was this one. So I kind of want to talk about this just because you guys won't be required to do the same thing that you would in Math 30-1. But if you had a question like this, right? So it said, if the activity of a radioactive sample of Q is 28 Barkel and 8 hours later its activity is 7, what is the half-life of Q? All right, so in this case they've given you the before and after, right? So before it was 28, after it was 7, and now this time we're looking for N, right? How many half-lives have gone by? And then from that we could rearrange and solve for like how long the half-life is. So in this case, once we get this set up, right, like if you want to get N on its own, it's up in the exponent, so it's kind of annoying, but you divide both sides by 28. This would simplify to a quarter. And now right here, right, we don't have to do any real solving in this case. Usually, like in Physics 30, if you're going to get a question like this, it'll be something set up pretty simply like this, where you should be able to figure out what N is just by looking at it, right? Like you should be able to figure out, okay, if I want this 1/2 to turn into a quarter, what would N need to be? Well, it would have to be 2, right? Because 1/2 to the power of 2 would be a quarter. So that's kind of the way you would solve those. We don't need to get into like logarithms or anything like that, right? Yeah, that's a Math 30-1 thing. Okay, so then once you had your N value, then you could set it up and just solve for your how long a half-life is. Okay, yeah, sorry, I just wanted to make sure I went over that, so because I think you guys have sessions in your practice problems like that. Okay, so hopefully that made sense, and yeah, I'll see you guys in class.